Right. Good evening. So today, actually, this is a recording, right? So today we're gonna do again another sets of conversions, right? So what I gonna do here? So these are recordings, so therefore no reason to wait, right? So wait until you finish the conversion, right? So what you have to do, I'll write the conversion, right? I'll write the conversion and then just pause the video and then try to do that conversion and then watch the recording, right? So what you have to do, because I will write the conversion and the answer, right? So I don't keep space, right? Because this is a recording, right? So pause the video and then try the conversion and then watch the answer, right? So therefore this recording will be then, I mean, the reason for that I can show the recording, right? So then it's easy for you, right? So you can watch the recording easily. Right? So the first one, very first, so these are actually, remember the previous set. So actually this is a right, this is a continue, right? It's a continuation of previous one, right? This is a part of the previous one, right? So I'll give the tute later. For now, just continue from the last one, right? This is the next one, not the new set. The first one, CH3 CH2 Cl, convert into CH3 CH2 CH2 CH3, right? CH3 CH2 Cl convert into CH3 CH2 CH2, right? So pause the video, right? So okay, I'll discuss the conversion now. So what happened? Just learn how to think, right? As I always said, you can't remind those conversions one by one, right? You can't remind. Therefore, learn how to think. When you see the question, you should learn how to think, how to find the pathway, right? These conversions are very easy actually. These are beginner level ones. Few steps. These are contain few steps. So here let's think about the differences between between the initial molecule and the final molecule, right? Okay. So what are the differences? First, check the carbon, number of carbon, right? Here, how many carbon? 2 carbon. Here, there are 4 carbons. That means number of carbon is doubled during the conversion, right? So you have to doubling the carbon chain. So here, this is a halide, right? If you have a halide, what is the easiest way to increase the number of carbon? Alkyl halide. So I explained few methods to increase the number of carbon, right? So there are two methods we usually use, right? Reacting that halide with that salt of the alkyl, right? Alkyl group, this kind of one, right? You can react in RCCCNA or something with this kind of one, right? Then you can increase the number of reaction. Other one is other common one, reaction with Grignard, right? You can react with Grignard again, then you can increase the number of carbon. So here the easiest way that I can see is go through this one, right? Go through this kind of molecule. So here there are 2 carbon, it's doubling, right? So if we can make this kind of one, we can increase the number of carbon. But again, if we go with that process, again there is a problem, right? Again there is a problem. I'll explain it, the problem, right? But I will do the conversion, but again I will explain the practicality, right? So here in this kind of case, so we need triple bond, right? So we have to convert this one into here, right? So the final one would be this one and CH3 CH2 Cl, right? So here, right? Then you can get the CH3, can get this CH3 CH2 CH2 and CH3, right? No, not directly. You have to join it, and again you have to add hydrogenation. You have to do hydrogenation also, right? So the first one you get just after reacting with these two, you will get this one, CH. Right? So then you have to convert it into here, right? So in this way, right, you have to break down the conversion, right? So when we break down this one, right, if you can break down into here up to here, then making this one is easy, right? You know that how to make this part. Just let's make a double bond, right? Using this one, CH to CH2, right? Then at Br2, CH2, sorry, CH2 Br, right? Then you can easily goes to here, right? It's not that much hard. One of the easiest method to get triple bond is adding Br2 and then remove Br as HBr, then you can get triple bond. Okay, it's easy. That's it, right? Easily, nothing wrong here. But you have to assume or hypothesize or just guess how it's from the previous one, right? So you have to think like that, right? මම හිතනවා වගේ මේක හිතාගත්තේ නැත්තම්, if you cannot break it, right, then you can't find the pathway. Always try to think backwardly, right? Always try to think backwardly, right? sometimes we can't think backwardly. So when you see this kind of molecule and that one, so you have to think the number of carbon is doubled. So then that means you made something using that one and join it, right? Find a way to join it. Okay, or you can again you can do another thing also. You can, but you can go with Greenard also, but few steps increased, right? Few steps will increase, but here also there is a problem, right? Here this is not complete, so you can't directly form this one, right? Here it's Na plus and C minus, so you can make H C double bond, then you can make it. So here, now look at the problem here, right? Can I get this one from this one directly? In the conversions, right? In the conversion, sometimes we do this, but it's not practical, right? Really, we have to do this one, right? Normally, it's not practical. Why? The reason is, so what you have to do to get this molecule, you have to add sodium, right? When you add sodium, what will happen? When you add sodium, does it react with only one hydrogen? No, it can react with both hydrogen, right? So let's say then you are adding 1-to-1 ratio. Let's say then someone said, okay, then what will happen if we add 1-to-1 ratio, sodium 1-to-1 ratio? That means one mole of this molecule, ethyl, and 1 mole of sodium. Okay, then there is, it's a logically correct, but how do we think? I mean, some molecules, I mean, this reaction not happen like a order, right? One by one molecule come and then react with sodium, right? No, it just happen, right? Some methine molecules get both sodium, right? I mean, in theoretically, right? So therefore there is a issue, a small issue, but don't worry about that, right? Because you may think why it's happened, how to get this one, and right. So there's a problem, but don't care about that. So we can get that, right? Yeah, we have to do that. So this is it, right? Now it's complete, right? Then so I'll move to next one, next conversion. So follow the same method, right? Pause the video. So this video might be 1.5 hours, 2 hours, right? Because it's easy to watch, right? But don't copy the answers. Try to do it by yourself and then watch it. So after I write the conversion, pause the video. Can you see the board? Yeah, you can see the board. Okay. Right. So now pause the video and try to do it. Okay. Then what kind of reaction is this? What kind of conversion? So it's about, it goes through the benzene, right? So when we do benzene conversions with benzene, right? So we have to consider about the what? About ortho pair, right? And meta, the reacting groups, right? And this positioning. Here, these two are positioned in meta, right? Meta positions, right? So this one plays relative to meta, right? This is meta, right? Meta to this one, right? This one meta. So then when we add something into benzene, we have to consider about that, as I said, right? So here these two are meta to each other. Then what we have to do, the first one is okay, it goes to, I mean, it doesn't matter, right, which carbon it's bonded, but the second one is the matter, second group, right? So second group should goes to meta position. So to do that, to make it happen, the first group that we gonna add should be a meta directing group, right? The first one we gonna add into the benzene should be a meta directing group, right? Otherwise you can send the next group into the meta position. Okay, right. Let's think. So we have 3 carbon, here also 3 carbon, right? 3 carbon alcohol, right? What you call it? Ethanol, methanol. Oh, sorry, methanol, ethanol, propanol, right? You can see propanol. So how to add this? So here the first group should be a meta reacting group. That's the point, right? So that means what is the very common meta reacting group that we used previously? It's something like this. C double bond O Cl R. What is this? These are called acid chlorides, right? This is acid chloride. So if we convert this one into acid chloride, we can easily send the next group into the meta position, right? Easily into the meta position, right? Or you can add another one. You can do the same thing, so but I will go with that method, right? First I will convert this one into this kind of one, what you call acid chloride, then I can bind it into this one, right? Right. So then how to make, our problem is how to make, so what is the group that we need? Something like this, CH3 CH2 C double bond O Cl, right? So how to make it? Just oxidize this one. In previous one I haven't mentioned the I forgot. I haven't mentioned the regions, right? Those regions are easy, right? So look at that table, that chart, right? It's easy. You can find it even from the textbook. The method is important. The way you think, that's the important thing. Okay, memorizing the region, you need to memorize region, but here it's not the main purpose, right? Memorizing region, it will memorize automatically when you do a lot of conversions, right? So first step, you have to oxidize this alcohol into carboxylic acid, CH3 CH2 COOH, right? How to oxidize? Just add KMnO4, H plus KMnO4, MnO4, right? H plus KMnO4. Then make it into acid chloride by adding what? Cl, right? Give me a second. Right? So you have to add Cl, right? How to add Cl? By adding PCl5 or PCl3, right? Something like that. Then you got acid chloride, and then add this group into benzene, right? How to add it? You have to add benzene with AlCl3, LCl3, anhydrous AlCl3, anhydrous AlCl3. Sometimes even I forget those regions, right? It doesn't matter, you can find those regions easily, right? Anhydrous AlCl3. Then you can get this kind of, sorry, right? So this carbon bonded with benzene, so CH2 CH3, right? Nice. Okay, then in next step we can add our CH3 group. If you find different method, it's okay. The only thing you have to check, right, the number of steps, right? In your method, if the number of method is less than my one, your one is correct, right? My one may be wrong, right? Because my one has higher number of steps, right? In the exam, they asked to do the reaction within less number of steps, right? Or sometimes they gave the number of steps, right? Less than 7 steps. They say something like that. So they say less than 7 steps. If someone do it in 7, then he got the first, total full marks, and you can do it in two steps. Again, you get the full marks, right? It doesn't matter, right? How much you less, but if someone do it more than 7, using more than 7 steps, what will happen? Then 0 marks. It's invalid because it's past the limit. Okay. So then you can add CH3 group also. How to add the same method? You can use same method. Anhydrous LCl3 with CH3Cl, right? Then how to remove double bond O? Double bond O, right? So by adding ZnHg and conc HCl, Clemmensen reduction. ZnHg conc HCl, then you get this structure, right? Clear? Right. Next one. Give me a second. If you do it in different method, just ask from me. Yeah? Actually, you can check it. There are two things you have to check whether that reaction is true, right? Because sometimes students are making new methods, right? New regions, right? So if it's a normal one, then okay. Then check the number of steps. So the next conversion, CH3OH COOH and Br. Okay. So pause the video and then try to do the reaction. Right. So I'll continue. Here, look at these two groups, carboxylic group and Br group. Okay. So what kind of positioning? So here it's para, right? Para. So the first group you're gonna add should be para directing group. Then it's okay, right? So if you initially add this one, you can't do anything, right? So this one is a COOH group is a meta directing group, right? So therefore, yes, you can't do that. So initially, here we have to start from this one also, right? Therefore, what I'm gonna do, I'm gonna add, so I'm gonna add COO, not COOH, I'm gonna add just CH3 into the benzene, right? If I add CH3 into the benzene, this one is a ortho-para-directing group. So then next one definitely goes into para position, right? Whatever I send. So therefore, first I am going to make this one, right? So how to add COOH into benzene is starting from this one. So I have to convert this OH group into Cl, right? This OH group into Cl by adding what? By adding PCl 3O5 නේ එහෙමද? Right. Okay, then I can make this structure. This one is a para reacting group. Then I can add Br in this one, this stage. H3. And then here, what I have to do? I have to oxidize H plus KMNO. For this oxidation is very important thing, because you can remove any carbon chain up to one carbon and its carboxylic acid, right? So it doesn't matter what is the chain, what is the number of carbon bonded into benzene. Anyhow, if you do this oxidation, it convert that carbon chain, the long, short, whatever, into COOH, right? Carboxylic acid group. Okay. Then how to add Br? You can add Br by Br2 and anhydrous Al Br3, right? Anhydrous. Okay, that's the way. Or you can add Fe Br3, whatever. Then this one, it's easy. You can add again anhydrous AlCl3. Right. So is this the only method? No, you can add Br, initially Br, and then you can do the same thing again, right? But you can't add Br initially, because you have to start from this one. That's why you can't start from Br. Otherwise, it's easy. If you start from Br, right? Br, it would be easy. Just add Br into the benzene ring and then do the reaction. Okay, next one. Again, another easy one. Right. So do it by yourself. Pause the video and do it by yourself. So I will continue. These two meta, right? This one, this group. Here is just one carbon. So This one is the orthopara, not orthopara, meta, right? Meta directing group. So then what we have to do, we have to convert this group into what? Orthopara directing group. This one is meta, right? So if you convert this into just R group, then R group is just a something like this, right? Simple orthopara directing group. Right? What we have to do? Clemmenson reduction. Zn Hg conc HCl, right? Zn Hg conc HCl. Then add Cl, then add Cl, sorry, and CH3%. Now then how to read like this, Cl2 anhydrous LBr3. Okay, then this one just H plus KMnO4, right? Simple, very simple equation, very simple conversion. Okay, next one. I'll move to next one. Same thing, but the initial reactant is different, but the product is similar, right? Here these two are orthopara, right? Then it's easy. What you have to do? Just add orthopara group into the benzene, right? So you can easily do that, but you can't add CH3 CH2 OH directly, right? You have to convert it into Cl, right? You have to convert this OH group into Cl by adding PCl5 or Cl3. Then you can get this kind of one, CH3 CH2, sorry, H2C Cl. Then you can add this group into benzene. Then you can obtain CH2 CH3, right? This carbon bonded into benzene, right? Now you have this structure. So this group is a orthopara directing group. Therefore, if you add any second group, that second group goes into this position mainly, right? Another thing, Lamai, I think I explained about that also. Most of the time, the second group try to goes into. Okay, I'll ask it as a question. So, which position is preferred by second group? If you, if the first group is orthopara directing group, the next group prefer the which carbon? I mean, which place? Ortho, para. I mean, ortho or para? Which one? Most of the time, the second group prefer this para position. Why? To reduce steric hindrance, right? Steric hindrance, because if it goes into ortho position, there is a steric hindrance, right? Not enough space, right? They can't even shake, right? It's like tight area. So therefore, second one preferred what? Para position. Right? Therefore, you can add para position. I mean Cl to para position. Right. So actually my doing recording is kind of a boring thing, right? But I have to do it, right? That's why I'm doing this. Okay. At least I will do this conversions and then I will stop. Okay. Because I have to do this. I have to finish these conversions. Huh? Otherwise, it's hard to move forward. Right, then you can easily obtain this one by H plus KMnO4. Then here FeCl3 Cl2O anhydrous, here LCl 3 anhydrous. Right, then the next one, I'll move to next one. Right, let's do this quickly. CH3 CHBr CH CH3 C Br CH3 CH2 CH3. Right, so yeah, just do it. Right, so when you see this kind of structure, what kind of? Here, so there are 3 carbons, right? This one is a tertiary alkyl halide, right? Tertiary alkyl halide. So basically in conversions, if you see any tertiary something, right? Tertiary anything, right? Most of the time, right? There is a huge chance it made using Grignard, right? Most of the time. I can't say all the time, I mean, but most of the time if you see something tertiary, because that's the easiest way to produce tertiary something, right? Basically, especially tertiary alcohols, right? It's very easy to produce tertiary alcohols using Grignard, right? tertiary or secondary alcohol, right? So if you see this kind of structure, most of the time it goes to the green art, right? So try to put green art, right? If you cannot do it within that specific steps, number of steps, then try another different method, right? That's what I do, right? So here initially I will think, first check the carbon chain, right? So here 1, 2, 3, 3 carbons, right? That's the 3 carbon, initial carbon, right? Then again you can see the same carbon chain here, right? So this one is separately added. Then what to do? Here what you have to do, I mean there's another method also, right? But I will go with the green art, right? So I will assume this one, I mean the previous step, that would be tertiary alcohol group, right? I don't know, I'll guess, right? It doesn't matter, right? This step. So then to make this one, I will assume I need two things, right? I need this kind of, this type of, what is this? This is ketone group, and I need something like this, CH3 CH2 Mg X. If you react these two, then you can obtain this one, right? Then it's already done, right? You can make this structure using this one, convert it into OH, convert it into OH, and then convert into ketone, right? Then how to make this one? You can get CH3 CH2 Br or something, right? X means Br, let's say Br, right? From the lab, and then convert into green art, right? Then you can get this one. So how to convert into OH? By adding just aqueous KOH, right? Then you can add PCC, pyridinium chlorpromate, or just H plus KMnO4. This thing valid because this is the maximum oxidation it can reach, right? So then you have to mix these two. After that you have to add, as a second step, water, H plus H2O. Then get this one, then again add PBr 5EC, right? Then I'll go to another conversion. If you can't understand, just ask me, right? In the class, just ask. I can't understand this part, something like that, right? Ask anything, I don't like to do this kind of recording, but I have to do. Right. So here, what you can see when you're looking at the product, check the number of carbon. Again, the number of carbon is increased, right? So, if so, use that method, right? There are two methods I taught. One is greener, another one is that triple bond, I mean alkyne case, right? Try to increase the number of carbon using those two methods, right? Here there is a double bond. You can guess before that double bond there was a triple bond, right? I will assume, I don't know, right? C3CH, not CH. Right. So before that, so how to make this one? So here we did this kind of one earlier, last week, right? Here this is the double bond. These, just say these two joint, just think these two joint separately, right? That means previously it may have something like this: C triple bond C, Na plus, Na plus minus minus, this kind of structure. And then this thing react with CH3, CH, then it gives this structure. Then just convert this one to carbon. Always concerned about the carbon, number of carbon. That's the, I mean, it's one of the very, I mean, it's a very important thing, right? And one of the key thing, right, to break down the conversion, right? Without concern about the number of carbon, sometimes you miss, right? You can't understand the conversion, right? Sometimes it's okay, but if that number of carbon is increased, just please study it thoroughly, right? What kind of chain, right? Then you can guess, this part is add later, right? This is the main chain, this is the main part, and these set add later, something like that. So think like that. එහෙම හිතන්න පුරුදු වෙන්න, right? Then make it. How to make it? How to make this one? This one. C3, CH2, Br. And then make a double bond, CH3, CH2, CH2 CH2, and then add Br2 alcoholic KOH, sorry, alcoholic KOH name, then it has to be and then easily get this. Not yet, there's another step. Where is the triple bond? Make a triple bond. Then goes to this one. This is step. Is it clear? Yeah, it's clear. Ne? You can. Okay, then is it over? It's almost over. I think I haven't explained the regions, right? So what are the regions? Here, no region here. Just this step. Here H2 PD PDBSO4 quinoline. Right, easy. Then next one, there are another 10 conversions. I will finish these conversions before move to past papers, right? Okay, look at this one. Okay, try to finish this one. Right, so what you can see when you're looking at the conversion, right? So here there are 3 carbon, and look at the product, the final one. 1 2 3 4 5 6. So here the number of carbon is doubled, right? It's doubled, right? So, and here it's alcohol, right? What kind of alcohol? This is a tertiary alcohol, right? As I always said, what is the easiest way to get tertiary alcohol? That is a reaction between Grignard and ketone. Right. So if so, break this molecule into ketone and Grignard, right? I mean, just assume it's made by reacting Grignard and ketone, right? Then what is the part of ketone and what is the part of Grignard? So here, this is a carbon chain, right? 3 set, and this is another set. I can see here it's one part and here it's another part, right? So in this one also, the main group is bonded into middle carbon. Here also middle carbon, right? Actually, this is the carbon present in here, right? That means Grignard attack into here, right? If it's like that, then what is the Grignard part? This one. This is the part of Grignard, and this is the part of ketone, right? So ketone is here. You have to make the Grignard. So what is the Grignard? That would be CH3, C, Mg, BRO, MgC, MgX, whatever. Right? Easy. So then the ketone is CH3. This one, nothing else. So let's make this Grignard, right? So how to make Grignard? So previously it would be a alkyl halide, CH3, C, B, R. Then you can easily make this one from this one, right? We did that earlier. How? You can first you have to reduce this one and make a alcohol. Make an alcohol, C3, COH, CH3. Okay. Then how to make alcohol from ketone? By reducing. So first step, anhydrous lithium aluminium hydride ALH 4 second step H2O. Then you have OH group, and then just easily convert it into Br by adding PBr, PBr3. Easy. Then add Mg, dry ether, Mg dry ether, right? And then H plus H2O, right? I don't care about some steps. I mean, step mean that region, right? You already know those regions. Those are very simple things. So think like that, right? This carbon is this, so this oxygen is this oxygen, right? So the same carbon chain is multiplied by 2, right? Then I'll move to next one. CH3, CH2, CH2, OH, convert to CH3, CH, CH3, CH, CH2, CH3. Okay. Here, look what happened. Right. So try it, and then okay. Look at the conversion. Here again the number of carbon is increased, but not like previous one. Okay. Here you can do the same thing also, right? Here it's a double bond, right? So the number of carbon is doubled, right? That's the how to say, what is that called, man? That's the hint, right? That's the hint you can make. The number of carbon is doubled. There are only two methods. You can easily double up the number of carbon, right? Grignard is the easiest one, right? So what to do? Just think, previously there was a oxygen COH right, previous one is something like this. No hydrogen here. You can't have hydrogen here. 1, 2, 3, 4. Right. So assume there was a OH group here, right? Then if so, again this is a tertiary alcohol, right? Again this is a tertiary alcohol. Therefore, what you have to do? You can use Grignard. before at Greenard, just break down the break down the parts. Which part is ketone part and which part is the aldehyde part. Sorry, which part is the ketone part and which part is the Greenard part. So this is the ketone part and this is the aldehyde part. Again, you can the same thing. I mean, if you think previously the OH group was present here, again you can do the same thing, right? I'll explain that thing also, right? The only thing here, only good thing, we don't have limited reactions. In the exam they will give limited reactions, right? So therefore you can, because I mean here there's no any limitation for what? Limitation for regions, right? But in the exam there is a limitation according to the region they supplied. You have to do the conversion, but here we don't have limitation, so therefore we can follow any method, but the only condition, it should be less step, right? You have to do the conversion, they supply anything, but you have to follow the shortest pathway, shortest route, right? That's the rule here. In the exam they will give the region, so you have to make a route according to the region they supplied, right? So that's the problem in exam, right? So here, then let's make these two separately, right? This one is the ketone group CH3, C, okay, and this is the Grignard part, CH3, CH2, Mg, X, right? Clear? Okay, then make these two separately, isn't it? And making Grignard is the easiest thing, right? Convert it into Br, and then this one. Then what? How do we get this one? This is propanol, right? Propanol. So it's present in the laboratory, right? So I said there's another method, right? Okay, before that I will finish this one. So you can add PBr, PBr3 and then Mg dry ether and then can mix these two, H plus H2O, and then remove OH group, conc first, conc H2SO4 second, no, that's for add OH, not for remove OH. Give me a second. Conc H2SO4 170 Celsius, right? Then again you can assume like this. There are, 2-3 methods can be exist, right? So The only condition is the route, shortest route. So we can do this conversion in different way. Let me explain. You can assume before they make double bond, there was a OH group in next carbon, I mean this carbon. What will happen? CH3, C, H, C, H, OH, CH2, CH3 and CH3. Okay, then which part is the ketone or aldehyde group? Now this is a now this is what? Tertiary or secondary? This is secondary aldehyde. So how to get secondary aldehyde? By reacting Grignard with aldehyde, right? Aldehyde, it gives secondary alkene. So sorry, secondary alcohols. Then which part is the Grignard part? This is the part of Grignard. Right? This is Grignard, and this part is right. This part is aldehyde. This is aldehyde. This is Grignard. Then you have to make Grignard using this part, right? And this, so you can make ketone, right? It's very easy. You have to convert this group, right? This CH3, CH2, CH2 OH group into aldehyde by oxidizing by PS. Okay, I'll do it. So I'll remove this step. This conversion. Will oxidize into H3CH2. How? By adding PCC. You can't add. This is oxidation, right? But you can't oxidize using strong oxidizers like H plus Km. What will happen? It doesn't stop at ketone. Aldehyde. If you use strong oxidizers, it oxidizes more and it gives CH3COOH, right? So it's a case. So you can't use that kind of oxidizers, only PCC. If you want to stop at aldehyde, right? If you plan to go to COOH, then it doesn't matter. Then you have to make Grignard separately. You have to get this kind of molecules from the lab, CH3, C, Br and CH3, and convert it into CH3, CH, MgBr, CH3, right? Then you can mix these two and make this one. You can make this one, right? Using that you can make this one easily. Okay, next one. CH3, CH2, COOH, CH3, CH2, CH2, benzene, and Br. Okay. Again reaction with benzene. So how to do this? As always, check the positions, right? Para, right? Para positioning. So then you have to add para something initial. So if you add this R group directly, this R group, so you know R groups are orthoparadirecting groups in Br. So we have to start from this region. So therefore, we have to start from here. Otherwise, you have to add Br into benzene and then again you can use it. But another thing, practically, I mean, we can add Br. I mean, we can use halogens as orthoparadirecting groups, but here is a catch. Practically, when you add Br into the halides into the ring, it will deactivate the ring. Then it's hard to add another one or second group into the benzene, but still we can use it and it doesn't matter. But if you have another option, that's better, right? Let's say the only option here, you can add Br and later next group, then it's okay. But if you have another option, if you can add R group initially and if you can add Br later, that's the best method, that's the best route, right? We can add Br, the summary, we can add Br initially if we don't have another option, right? If you have an option, we can do that, right? The problem is Br is deactivating the ring, but it's okay, you can use it, right? Use can back කියලා හිතන්න එපා. Right. So then what we'll do? Convert this into OH. Then make CH3, CH2. What is the method to bind Grignard into the R group? It's Cl or halogen. Br. Right. Then what? Now you can, okay, I'll add Cl. Now you can add what are the regions? Anhydrous AlCl3, right? Here PCl3O5, here lithium aluminium hydride. anhydrous, second one H2O. Then what? Nitrous, you can add into the benzene ring easily. CH2, CH2, CH3, and then add Br, right? Okay. Here it's easy, right? Same thing. Here it's horizontal, and my one it's vertical. Then add Br, then Br goes into ortho. Sorry, not ortho, para position. Right. Next one. Right. What is this? C H2 like this. Okay. How to make it? Here, assume the previous benzene one is, Lama always try to put green art, right? If the number of carbon is increased, try to use green art, and then first check about green art. Next one, that triple bond one. Okay, just keep it in mind. So I will guess the previous one would be like this: OH, CH, CH, CH2, CH2, CH3. Clear? Okay. Then, how to increase the number of carbon? Here, if you see carefully, there are 2 carbon increased, right? This part. Okay. දැන් මොකද කරන්නේ එතකොට? මේකනේ වැඩි වෙලා තියෙන්නේ. දැන් what is this? What kind of alcohol is this? This is secondary alcohol. How to make secondary alcohol? By reacting green with aldehyde. So check that. එහෙම බලන්න. එහෙම හිතලා බලන්න. එහෙම බලලා සෙට් වෙන්නේ නැත්නම් ඉතින් එහෙම නෙමෙයි. හරි? හැමතිස්සෙම ඔය මගුලෙන් හැදෙනව නෙමෙයි ඉතින්. ඒක දාලා බලන්න ඉස්සෙල්ලා ලේසි විදියනේ. Right? So what are the parts of green and what are the parts of aldehyde? This is the part of aldehyde. This is the part of green. So right, plus කොහොම තිබ්බ කියන්නේ මේකෙන් අර හදන්න තියෙන්නේ. මේකට කලින් ස්ටෙප් එක EVR එක හැදෙන්න කලින් එතන CH3CH2Br හරිනේ. එතකොට ඒක කොහොමද පිටින් ගන්න වෙනවා. මේක තමයි හදන්න තියෙන්නේ. ඉතින් අවුලක් නැහැ මේක. PCC තමයි මේ දෙක සෙට් කරා අතෙන්ට යවුවා. right. මේ ටික බලා ගන්න. right. මම පොඩක් ක්ලාස් එක මේ දැන් මේක මේ ටයිම් එක අඩුනාට ක්ලාස් එක දිගයි ඇත්තටම. right. මේ ටික කරන්න මම කිව්ව විදියට මේ එහෙනම් අදට නවත්තමු අපි. මේක මේ ලොකුවට කරන්න ආස නැහැ. මේක රෙකෝඩින් එකක් හින්දා right. අර විදිහට බල කරන්න මම මේක ටියුට් එක දාන්නම්. right. එහෙනම් අදට අපි නවත්තමු. right. good night.